So this is a lecture for section 3.5, MSc 1105. So what I'm going to do with this one is, since the previous video did not have any audio, instead of rewriting everything, I'm just going to kind of go through what I already have here. So usually we have a base function. We can do different things to the function, to the graph of the function. So in case, let's say, for example, we have f of x is equal to x, then if I were to add n, and n is greater than 0, n is an integer or a real number, then f of x is shifted up n units. So for example, if I say f of x is equal to x, and then I do f of x is equal to x plus 3, then it'll be shifted up 3 units. And so I'm going to show you what that looks like here with GeoGebra, if I find it. There you go. So if the function is, that's x, right? F of x is equal to x. But if I also have f of x, or x plus 3, you can see how it's shifted, up 3 units. So that's what happens there when I add a value that is positive value, if you will. Now, vertical shift down is if I have the function f of x, and then I subtract a number n, real number, and n is greater than 0, so n has to be positive, then f of x is shifted down the absolute value of n units, right? And so again, if I have this one here, so this was going to be x minus 3, you can see how it's shifted down. So the green one is the original, the blue one is the plus 3, and the red one is the minus 3. Now the next one here is a horizontal shift to the right. So again, if the function f of x is replaced by f of x minus h, and h is greater than 0, then the graph of x minus h is shifted to the right h units. And so if I go back here to my functions, I say x minus 3. Sorry, let me do this. So let me get rid of these 3. So if I have x squared, right, that's my x squared. Then I have x minus 3 squared. You can see how it's shifted to the right 3 units, right? So the blue is the original, the grayish looking one is the x minus 3. So the next one is horizontal shift to the left. So in this case, what I'm going to do is f of x is replaced by f of x plus h, so it's going to be shifted to the left h units. So let's go ahead and use the same example. So it will be x plus 3 raised to the second power, and then you can see how it is shifted to the left 3 units. So the middle one is the original, x squared. The gray one to the right is x minus 3 to the second power, and the green one to the left is x plus 3 to the second power. Now, a vertical compression is if f of x is multiplied by a, and a is between 0 and 1, then a new function, y is equal to a times f of x, is vertically compressed. And so let me show you what that looks like. So let me get rid of these here. Actually, let me leave that one there. And so what I'm going to do for the sake of space, I'm going to do 0.5, right? And so you can see that I lost the original. Let me get the original. Actually, no, the original is there, so sorry. So you can see that the original, and then in this case, it's vertically compressed. And so the next one that we can look at is vertically stretched, right? So if f of x is multiplied by a, and a is greater than 1, then the function itself is vertically stretched. And so you can see here, so if I do 2x to the second power, you can see how it increases at a faster rate, whereas the bluish one, when it's 0.5x squared, it increases at a slower rate than the original, and even if a is greater than 1. Now, a horizontal stretch, horizontal compression is if f of x is multiplied by a is greater than 0. And so what happens here is the following, right? So again, I'm going to leave the x squared. So I'm going to do 0.5x to the second power. So you can see what happens there, right? It kind of expands a little bit. And so that's a horizontal compression. Horizontal stretch is if a is between 0 and 1, right? So that's what happened there. And then I'm going to do 2x to the second power, and you can see. So if a is greater than 1, you can see how the function increases faster. If a is between 0 and 1, it can't be 0, then it sort of stretches a little bit because it increases at a slower rate. Now, here for number 19, the base function is y is equal to x to the third. When we shift it 4 units to the right, the equation becomes x minus 4 to the third power. We want to shift it 4 units to the left, we write it as x plus 4 to the third power. We shift it 4 units up, it would be x to the third plus 4. And if we shift it 4 units down, it would be x to the third minus 4. So let's see what those look like. So here I have x to the third, which is the original. And so first thing I'm going to do is I'm going to do x minus 4 to the third power. See how it shifts, right? Do x plus 4 to the third power. See how it shifts to the left. X to the third plus 4. Oops, not there. Plus 4. You can see the red one, how it moves up 4 units. X to the third minus 4. See how it shifted down 4 units. And I believe those are the 4 that I went through for this one at the beginning. Now, if I wanted to stretch it vertically stretch by a factor of 4, I would do 4x to the third power. You can see how that's going to look. Let me get rid of some of these here so it becomes a little easier to see. You can see what happens there. Now the next one, if it's horizontal stretch by a factor of 4, it's going to be a little different than the one that we just finished doing. So this is going to be, oops, that's not what I wanted to do. And so that's what I wanted there. Let me do this one. So then this one's going to be 1 divided by 4, x to the third. And you can see the difference between those, right? That's the greenish one. Now, the last one would be y is equal to the square root of x. And so let's see what that looks like if I do the different ones. Let me see if I can just pop up a new one. Clear all. There you go. And so I do the square root of x, and that's the square root of x, right? Now if I do the negative square root of x, you can see how it reflects, right? The next one, it would be negative square root of x minus 3. So you can see how it shifts to the right. And then negative square root of x minus 3, and I believe it's minus 2. Then you can see how those look. And you can see the difference between the original, which is the blue, the negative, which is the red. The negative x minus 3 shifts to the right, and then the negative square root of x minus 3 minus 2 will shift down 2 units. And that is the end of 3.5. Thank you.